This is part 9 of the series Calculus Prerequisites, and we're going to start out this piece with a discussion of completing the square, solving quadratics by completing the square. Now, completing the square is a very important operation, not just to solve for quadratics, but very often in our manipulation of algebraic expressions, we have to put things into a vertex form in order to be able to solve them easily in a calculus environment. So that's one of the primary reasons we're going through this, but there's other reasons as well. It's always good to be familiar with these older concepts that you've had in the past. So let's take a look at the process. What we're going to do is we're going to take a fairly standard trinomial here, and we want to convert it to a perfect square trinomial. What that means is the first term and the last term are perfect squares, and the middle term is made up of the product of the square roots of the first and the third terms. Now, there are many different styles and ways to implement this. I'm going to show you one. You're free to pick whichever one is comfortable for you. Now, the way I do it is if I don't have a coefficient up here, I will simply rewrite these first two terms, and I will pull the third term outside of the parentheses, give myself some space, and write my 0. Now, this third term has to be a perfect square, and this value has to be the square root of this times the square root of this times 2. So I'm going to reverse the process. I'm going to take this, divide it by 2, and square it. So 14 divided by 2 is 7. 7 squared is 49. Now I've added a value of 49 to the left side of this equation. So to keep the equality true, I'm going to subtract 49, but I'm going to do it on the outside here. So that I've accounted for the addition of the 49, I've subtracted the 49, and I haven't changed my equation one bit. Now I have a perfect square trinomial. This perfect square trinomial breaks down to a squared binomial. And the way that works is you take the square root of this, that sign, and the square root of that. And that's squared. So multiplying this together gives you this piece. Then I have these two that I have to reconcile. So conveniently, 51 and 49 add up to 100. So this is minus 100. Now you have the vertex form of that quadratic. In other words, the vertex of your quadratic is at -7, -100. Now, what we can do is to solve this equation, we just solve for a. And we solve this just like any other algebraic equation. So we have a plus 7 squared equals 100. Then a plus 7 equals plus or minus the square root of 100, which gives us, and we're going to subtract the 7, a equals -7 plus or minus 10. And this gives us -7 plus 10 is 3, and -7 minus 10 is -17. Now you may remember this problem when we were solving quadratics by factoring. We worked the same problem and got that same value. All right, let's move on to the next problem here. So following the same process, I'm going to take x squared minus 12x, give myself some room, take out the 11, give myself some space, equals 0. Now take this value, divide it by 2, so that's 6 squared is 36. Now since we added 36, we've got to subtract 36. Break this down, square root of the first term, that sign, square root of the third term. Now we reconcile this, so this gives us -25 equals 0. Again, nice and convenient value here. Solve this. X minus 6 squared equals 25. X minus 6 equals plus or minus the square root of 25. And let's go back up to the top here. And x equals 6 plus or minus 5, which gives us 11 and 1. Now down to this problem. Well, this is not going to be in standard form yet, so we've got to put this in standard form. So do a little manipulation first. We have 5k squared plus 20k minus 60 equals 0. Now we do the same thing. Now here we have a leading coefficient. So there's going to be a couple of extra steps in here. And the way I like to do this is my first step is I leave the leading coefficient intact and I simply do my separation. 5k squared plus 20k, separate out my 60. Then I pull out my 5. I'm going to pull out, using the distributive property, I'm going to pull out that leading coefficient because our leading coefficient has to be 1 here. So let's pull out the 5. That gives me k squared. Now we're dividing this by 5. So we've divided this by 5, we've got to divide this by 5. So 20 divided by 5 is 4. All right, now we do the same thing we've done in the past. We take this, divide it by 2, which is 2, squared is 4, so we added 4. Now there's a slight complication. We've added 4 to the left side, but it's not just 4 that we've added, because every term inside these parentheses is being multiplied by 5. So this 4 is actually adding 4 times 5 to this side. So since we've added 20 to this side, we had better subtract 20 from this side. So this accounts for the addition of the 4 inside the parentheses, because that 4 is multiplied by 5. Now we solve just like always. So we have the 5 outside. Break this down into its squared binomial. Square root of that, okay, that sign, square root of that, squared. This and this gives us minus 80 equals 0. Now we solve. And so we have 5k plus 2 squared equals 80. We divide by 5, so we'll have k plus 2 squared equals 16. K plus 2 equals plus or minus the square root of 16. And let's go up over here, and we have k equals negative 2 plus or minus 4. And negative 2 plus 4 is 2, and negative 2 minus 4 is negative 6. Now, as you go through this process, it's always a good idea to make a very special mental note when you get to the vertex form, because this is going to be a critical piece right here. So make sure that you know each time when you've gotten to the vertex form. So here was our vertex form, here's our vertex form, here's our vertex form. All right, let's do one last problem here. And again, in this problem, we have to manipulate a bit because we're not in standard form. But beyond this not being in standard form, I'm noticing something. Every one of these terms is a multiple of 6. And it appears that I can divide everything here by 6. So in actuality, this is going to be x squared. 48 divided by 6 is 8. And so now we have a simpler equation that we can solve. So we have x squared plus 2x minus 8 equals 0. So that looks a lot better than this original. And you could have solved it without simplifying it like this. It just would have been a little bit more difficult because your numbers would have been bigger. So anyway, we do the same exact thing. I'm going to separate out my values, pull out my -8, give myself some space, and this divided by 2 is 1. 1 squared is 1. We're going to subtract 1 here. And so now my vertex form becomes square root of this, that sign, square root of that, squared. That's -9 equals 0. So there's my vertex form. Now I solve, adding 9. Take the square root of both sides. And going back up to the top here, we have x equals, we're subtracting 1, -1, plus or minus 3. Now all these worked out really cleanly. They're not going to work out that way all the time, but they're nice, easy examples just to get you back into practice with completing the square. So this gives you 2 and -4 as your solutions. Now before we wrap up the process of completing the square, I'd like to work out one final exercise. This is going to be a really valuable exercise for you to both build practice and experience in greater rigor than really simple problems like this, and more symbolic representations than using specific numbers and things. But we're going to go ahead and do that in the next video. So I will talk to you in the next video.